The 9.3 extension, I'm basically going to walk you through 4 examples of the 4 different equations that we have: the circle, the ellipse, the hyperbola, and the parabola. This can be found, these 16 problems on this page can be found on the back of your homework packet, called the extension homework maybe or something. But all right, so one of the things you'll notice is a lot of the equations that you start out look similar, but for example, this one, there's both an x squared and a y squared, and they're both positive. This one over here is the same thing. So how would you tell the difference between these 2 equations? Well, this one technically has 1 and 1, so the coefficients on the x squared and y squared are the same. So that means we're dealing with a circle. The second equation, they're different. This one would have a 1 and this one is a 4. When they're different, you're dealing with an ellipse. Number 3, there's x squared and y squared, but it's important to notice that one of them is negative. When one of them is negative, you're dealing with the hyperbola. And the last one, there's only one variable being squared. When the one variable is being squared, you're dealing with a parabola. So I'm going to do these 4 examples. I'll do the completing the square, and I will draw a graph of each one. All right, so the first one. Let's go ahead and get that first one set up. Okay, so I copied the first one over. It's x squared plus y squared minus 6x plus 4y plus 9. So my x's, we're ready to complete the square because it's x squared, 1x squared, minus 6x. We'll add a new number there. The y's are plus y squared plus 4y plus some new number. And then let's move the 9 to the other side. Then you take the negative 6, you divide by 2. I got negative 3. Square it is 9. So when I put a 9 here, there's nothing in front. So I'll add 9 over there. Then you take your 4, divide by 2, and you get 2. Squared, you get 4. So I'm going to add 4 there. Again, nothing out front, so add 4. So we're looking at x minus 3 quantity squared plus y plus 2 quantity squared is equal to 4. So that's our circle. Okay, so that circle now, I'm going to write on the other page and I'll show you what the graph would look like. So that was the equation that we found. That was the standard form. And the center now, remember, will be at 3, negative 2. And this is r squared, so r is 2. So go to the right 3. 1, 2, 3. 1, 2, 3. Down 2. So that's my center. And then I will go up 2, right 2, down 2, and left 2 to get my circle. Oops. Left 2 to get my circle. So just draw the best circle that you can. Now, if the center is at 3, negative 2, going up 2 will be 3, 0. Going to the right 2 would be 5, negative 2. Up, you add it to the y. Right, you add it to the x. Going down, you add your r value, or subtract it, excuse me, from the y. And going left, you would also subtract it from the x. So those should be your 4 dots when you do the top, bottom, left, and right. Okay, so example 2 now would be x squared plus 4y squared, and so that's the ellipse. So I'm going to copy that to the other page, and I'll show you how to complete the square. All right, so there's the ellipse that we're working with. So I'm going to look at my x's, and again, it's 1x squared already, so we're good there. the y's, I'm going to have to factor a 4 away from the y squared. So I have to do the same thing to the 16. 16 divided by 4 is also 4y there. Some new number. And then we're just going to remember send the 21 to the other side. So take your negative 6, divide by 2 is negative 3, square it is 9. Take the 4, divide by 2 is 2, square it is 4. So I'm going to add 4, and then that dotted line would be 16, so I have to add, oops, I forgot to add my 9 over here, and now I have to add 16 over here. So now I have x minus 3 quantity squared, just using that number right there, plus 4, y plus 2 quantity squared. And when you add all this up, I'm left with a 4. But with the ellipse and the hyperbola, but for this one, the ellipse, we want it equal to 1. So you're going to divide everything by 4. So you turn out to have x minus 3 quantity squared over 4 plus y plus 2 quantity squared over 1 is equal to 1. Now, normally we don't write this 1 as a denominator, but for this one we do want denominator, so we're going to leave it there. All right, so I copied the standard form to the other page here. So my center now is to the right 3, and we'll go down 2. So 1, 2, 3, down 2. So this time maybe we'll just write center 3, 2. Now, under the x is this 4. So remember with the ellipse, it's about which one has the bigger or major denominator. So whatever's biggest, we're going to square root that. So a will be 2. So I'm going to go to the right 2 and to the left 2. So those are called vertices. Do the bigger denominator first when you're doing the ellipse. So that would be 1, 2, and that would be 5, 2. Now under the y is a 1, so b technically square root of 1 is 1. So you're going to go up 1 and down 1. We call those co-vertices. And going up 1 from the center would put me at 3, negative 1. I forgot my negative when I wrote my center. I forgot my negative there. And then when you go down 1, that's 3, negative 3. So you can go ahead and draw the elliptical shape in here. Now we're going to find the c value, and the c squared formula is a squared minus b squared. So c will be the square root of the big denominator minus the small denominator, or the square root of 3. So I'm going to only move the square root of 3, which is 1 point something. So go to the right, you'll have a focus there, and go to the left, and you'll have a focus there. So those focus points, I'm going left and right. So I'm going to do my 3 plus the square root of 3 comma negative 2. And then I do the 3 minus the square root of 3 comma negative 2. And that's the ellipse. Okay, so the next one was the hyperbola. And that will be from the 9.3 lecture. So I'll copy that to the other page and show you how to do completing the square. So the 4x squared and the y squared, one's positive, one's negative. That's how you know it's a hyperbola. So I'm going to take my x's and factor a 4 away from the x squared. Now I have to take negative 4 and divide by 4, which would be negative x. And we'll add some new number there. Then we just have negative y squared, and we'll move the 3 to the other side. So on this problem, my b value is negative 1. When I divide by 2, that is negative 1/2. When I square it, I get 1/4. So when I add 1/4, notice that the dotted line is 1. So I'm going to add 1 over here. This time I don't have to do any completing the square with the y's. So now I have 4x minus 1/2 quantity squared minus y squared is equal to 4. And just like the ellipse, we want it equal to 1. So the hyperbolas we want equal to 1. So divide everything by 4. So this will be x minus 1/2 quantity squared over 1 minus y squared over 4. So that should be your standard form. So with the hyperbola, we're going to find our center, and it's to the right 1/2, 0. So it'd be right there. So let's do center 1/2 comma 0. Now I suggest you do the vertices first, and with hyperbola, it's all about what is written first. What's the positive term? So this would be my a value. Square root that is a 1. So I'm going to go 1 to the right and 1 to the left. So my vertices would be, I guess you could call it 1.5 comma 0 and negative 0.5 comma 0. Now we don't call them co-vertices, but this b value right here would be 2. And there are different ways, but we're going to go up 2 from the center, down 2 from the center, and then we can do the imaginary box. But the main thing is these corners of the box, you could also count out your slope. Go up 2 over 1, up 2 over 1, down 2 over 1. But the corners, you want your x, these imaginary lines, the asymptotes, to go through the center, through the corners of those boxes. Then you go back to your vertices and you draw in the hyperbola following that imaginary line. And then the final thing we can work on is finding the focus points. And the focus for the hyperbola is c squared equals a squared plus b squared. So c will be the two denominators added together, or c will be the square root of 5. So just a little more than 2. So you're going to go 1, 2, and a little bit more. That's one focus. 1 from the center, 1, 2, a little bit more. There's another focus. And so this one would be the center, 1/2 plus the square root of 5. And this one would be 1/2 minus the square root of 5 comma 0. Now, one other thing they do talk about, and you need to know slope when you talk the asymptotes. So I always teach it that the slope is plus or minus the a or the b that comes from y. So 2 goes on top, 1 on the bottom. So slope equals plus or minus 2. So when you look at these slopes, you can find that. And if you have to find the equation of the asymptotes, the equations of the asymptotes would simply use the center. And so one equation would be y minus 0 is equal to positive 2x minus 1/2. And the second equation then would be y minus 0 equals negative 2x minus 1/2. So this one turns out to be y equals, this is 2x minus 1. And this one turns out to be y equals negative 2x plus 1. Because I just went to what's called point slope form, used the slope that I found and the center as my solution point. Okay, the last one, parabola. Now we've had many forms of parabola, but there's only one thing squared. So That's how you know you're dealing with a parabola. So I copied the parabola over here, and now we're going to y squared minus 4y. I need to add some new number. And I'm going to take the 4x to the other side. I put the squared term on the left and the single on the right. You may have been taught differently, but that's how I do it. Now, if I take the negative 4 and divide by 2, I get negative 2. Square it, I get a 4. So what I'm going to do is add that here and add that here. So now we're looking at y minus 2 quantity squared is equal to, now in this thing, we want to make sure that it's x to the first power. So we factor the 4 away from the x, and 4 divided by 4 is also 1. So this is our standard form. So I copy that to the other page. Now, one of the things is when y is being squared, this is a horizontal parabola. So my vertex, go to the x first, negative 1, 2. So my vertex is at negative 1, 2. That tells me, because it's horizontal, that the axis of symmetry will be running this way, and that's at y equals 2. Then we take our 4 right there, and we say 4p equals 4. Divide both sides by 4. P equals positive 1. So that tells me that this thing is opening to the right. So this, when it's positive and sideways or horizontal, I know it's opening right. So then I can go ahead and move the p-value, so I can go 1 to the right and put a focus. Okay, so I think I accidentally had the center in the wrong spot. You should only go 1 to the left, up 2, so now I have it in the correct spot. This tells me the distance right here. We are moving 1, so go to the, and the focus always has to be inside your parabola. So if you go to the right 1, now you're at 0, 2. So add it to the x. And then if you went to the right for the focus, you go to the left for what's called the directrix. And it's this imaginary line. So now go from the vertex backwards 1, and that's where x is negative 2. So that would be your parabola. So I've done 4 examples off that worksheet. You can do the other, I guess, 12 and see how you do.